Hi everyone, I'm Dr. Romana Sarkar, currently working as a research fellow at the Monash University. And today I'm going to present the result of our recent study on women rail users in Melbourne to understand their perceived personal safety when using train in light of their harassment experiences in recent times and also experiences in their adolescence. So, from the past researches on personal safety, we know that globally up to 95% of women have experienced some form of unwanted sexual behavior on public transport. So, personal safety has been always a major concern for female rail passengers, particularly during night. So, the aim of this project was to explore a personal safety experience of women rail passengers in Melbourne. We also wanted to explore if there is any changes in perception since the COVID-19 and if it has shaped any long-term travel behavior changes. So now I will briefly describe the survey approach. So an online panel-based survey was administered among the women rail users in Melbourne, and it was administered by the market research company, but hosted at the Monash University. And overall, we have collected around 880 responses. And after screening, we have finally achieved a target group response of 563. And in this sample, we also had gender diverse users, but this presentation only focuses on women users. Now, if we look at the conceptual framework where the survey was based on, so this framework actually introduces the concept of perceived precautionary safety, or PPS, that actually shows the coping measure that comes from the harassment experiences. So PPS here captures behavior like taking different route, being very hyper vigilant when using public transport, or avoiding traveling after dark altogether. And here we also wanted to see if there is any effect of harassment experienced in adolescence, and maybe there is a lasting impact on the adulthood as well. So this was measured through the Street Harassment Index, both the recent harassment, that is in the last 12 months, and also harassment in adolescence. This model also hypothesized that harassment experiences can actually shape individuals' emotional state and personality trait, and this was measured with the state trait anxiety scale. Finally, we have also included different travel-related factors such as rail use frequency, time of day, and other socio-demographic factors such as age, income, education, and also cultural diversity. The model was estimated using structural equation model. So moving on to the results, when we look at the travel behavior of the sample, 25% of the responses, they use a train 3-4 days a week, and over 20% actually uses rail 5 days a week. In terms of using train after dark, around 37% travel by train after dark 3 days weekly. And when we look at the access to car, majority of them have car access. And we can say in this sample, we have around 5% captive riders. That means they don't have any access to car, and then they are forced to use public transport. When we look at the age distribution, 40% of the women rail users are in their mid-30s, another 27% are in their mid-20s. In terms of origin, around 13% identified themselves from culturally and linguistically diverse background, and around 8% identified themselves as Aboriginal or Torres Strait Islander people. In this survey, we have also asked participants about their overall sense of safety when using public transport, and the result reveal a very pattern. You can see a very solid pattern, and result shows that generally women feel safer on rail when they take precautionary safety behavior. And this was actually reflected by participants' strong agreement to the statements such as, I feel safer traveling during the day if I take extra measures, or I only feel personally safe during the day when traveling with metro trains. So this actually led to the construct PPS, which I have already explained in the conceptual framework. It also reflects another concept called safety work that actually shows an invisible effort, which is often undertaken by women to manage their perceived risk when they're using public transport. So most importantly, this not only focus on the individual attention, but it also shows a broader issue, that is the burden of being safe is placed on female rail passengers rather than on the whole system. In terms of different types of harassment that were experienced when using rail, we can see that frequent intimidating stares dominate women harassment experience. Surprisingly, 1 in 25 women users self-reported that they have experienced direct or explicit pressure to have sex on transit in the last 12 months. This portrays a very grim picture of women personal safety in Melbourne. And in terms of physical assault, most of the sample don't experience serious harassment, but at least 16% experienced physical assault on public transport of some kind and were hospitalized at least once. In our survey, we also asked about harassment experience in adolescents, that in teenage years, and nearly half of the respondents actually experienced harassment in their adolescence in the form of verbal harassment, mostly staring or catcalls. A high majority had no serious assault experience in teenage years, but some of the women riders, around 5%, they have experienced hospitalization from physical assault with a weapon when using public transport in their adolescence. So this could actually have a lasting impact on a women's mental well-being and anxiety level. So we wanted to understand in our survey by asking the participants, how do they generally feel in their day-to-day life? The result shows that generally women feel secure and calm in their daily life, while 39% feel tense quite frequently, and another 37% worry over possible misfortune. So these effects were later tested in our SEM model. We have also asked women about their experience of harassment and its impact on their current rail use, and nearly half of the women riders reported that the harassment experience actually affected their current rail use. And of this sample, 25% of women said that they travel significantly less now than they used to. So this slide shows the path analysis from the structural equation model. Due to the time limitation, I'm not delving deeper into the other aspect of the model. But here you can clearly see that verbal harassment experience and physical harassment experience are the strongest predictor of perceived precautionary safety or coping behavior. From the results, we can see that verbal harassments were frequently experienced among the women rail users rather than physical harassment. And we can say that women with prior experiences of verbal harassments are more likely to adopt these precautionary behaviors. Hence, we have a positive coefficient that is 0.49. On the other hand, although physical assaults were less experienced, but women who have experienced physical assaults, they are less likely to feel safe, even when engaging in coping behaviors, which is shown here with the negative sign, minus 0.32. What we've also seen that both the verbal and physical harassment has effect on the personality trait. And women who have experienced verbal harassments, they are more likely to exhibit anxiety-related traits. However, women who have experienced physical assaults, they exhibit both the anxious and secure trait, but there is a stronger association with the anxiety-related traits like verbal harassment. What is most striking in this result is that women who have experienced harassment in their adolescence in the form of intimidation, they feel less personally safe on transit, even when they're adopting coping behavior. So this model actually shows that there is a lasting impact of harassment on women's later life or in adulthood. Another result that we found that is significant, that people who are using tram or women who are using rail after dark, they have negative perceived precautionary safety. That means they feel less safe even when they're engaging in coping behavior. And finally, women from diverse cultural background, they also reported lower PPS or feel less safe when using rail, which is also in line with previous researches. So to conclude, we can say that this study offers new insights into the factors shaping women's perceived precautionary safety on transit in Melbourne from a different perspective, where we are looking at the life stage effect. So if you're harassed in the teenage years, probably this has an effect also in your adulthood and your travel behavior in the adulthood. The findings highlight the need for policy intervention that includes trauma-informed intersectional approaches to transit personal safety. And some of the key policy recommendations that we can derive from the results are to promote early education and prevention. That is, we could launch awareness campaigns in school for young transit users to address harassment during adolescence, and maybe through this program, they can get some type of therapy or consultation to cope with this situation. In terms of infrastructural improvement, lighting has been always something that are prioritized by women. So improving lighting, visibility, and ensuring proactive staff presence at the station could actually enhance after dark travel safety. From the transport planning decision perspective, integrating diverse lived experiences are very important. So in the planning phase, perspective from Indigenous women's and from diverse cultural background should be included. For the transport operators and planners, we should move beyond infrastructure by not only focusing on providing more CCTV or more technological surveillance, rather than implementing bystander intervention and gender-sensitive staff training. And finally, there should be participatory co-design support to have better inclusive planning and also empower women riders to shape a safer transit environments. So that's the end of my presentation. Thank you very much for listening. If you have any question or queries, you have my email address on the screen. And please do visit our public transport research group websites for any upcoming research findings that you'll feel interesting. Thank you so much for listening.
Thank you very much. Thank you very much. Sorry that I'm joining a little bit late. Actually, I was with you before, but because of a technical issue, I couldn't talk at the start of this session. Sorry about this. It was supposed that actually the chair of this session be Professor Rebecca Bian, but in the last minutes, actually, she's replaced by myself. And so anyway, let me introduce myself. I'm Ali Najmi. I'm a lecturer at UNSW in Australia, and I'll be chairing this session. Sorry that I'm telling you a little bit late, but I have to tell this. Each presenter will have, okay, the first one is finished, but the others have 14 to 17 minutes time to actually present their topic, followed by a brief 2 to 3 minutes question and answers. Feel free to write your questions during the presentations in the chat box of the Zoom if you like. Otherwise, you can easily simply raise your hand and ask your questions in the Q&A session. And also a gentle reminder to the other presenters, please keep an eye on your time. So, however, at the end of your talk, I will just send a gentle reminder via text message that you have 1 minute time, 2 minute time until the end of your time. And thank you very much for this insightful presentation. Does anybody have any question here? No question? All right. Thank you very much for the time. All right. The next presenter is Madhuri Krishna Kishore, right?
Yes,
You are here.
yes, sir.
Let me just give a short bio of you. Actually, Mr. Kishore is a doctoral research scholar in the Division of Transportation Engineering and Management at the Department of Civil Engineering at the National Institute of Technology in India. Okay, go ahead. Thank you.
Thank you, sir, for the introduction. Am I audible, sir?
Yeah, it's good. Just share your screen. Yes.
Uh,
Go ahead.
Yes. Thank you. Good morning to one and all, and good evening, good day to everyone. Myself, Madurai Krishna Kishore. I am a doctoral research scholar in the Department of Civil Engineering at National Institute of Technology, Tiruchirappalli, India. My topic is understanding how parents and peers shape risky riding behavior in motorized two-wheeler riders. So generally, risky riding behavior refers to the deliberate actions of motorized two-wheeler riders that are deviate from the safe practices which are essential for maintaining the safe traffic system as well as a safe vehicle. So let's see how the parents and peers shape risky riding behavior in two-wheeler riders. So coming to the introduction, we all know the motorized two-wheeler is a two-wheeled vehicle powered by either gas or electricity and includes both geared and non-geared vehicles. As per World Health Organization report 2023, motorized three-wheelers and two-wheelers account for 30% of overall road traffic fatalities. So in India, road safety is a major concern, and the traffic crashes are responsible for most of the fatalities. So as you can see from the statistics, the country experienced 4.61 road crashes. This is a steady increase from 4.49 lakhs in 2019, resulting in 1.68 lakh fatalities and injuries to 4.43 lakh individuals. According to the Ministry of Road Transport and Highways Department, the Government of India reported 2025 motorist two-wheeler riders were responsible for over 80% of road traffic fatalities, especially due to risky riding behaviors. So peers play a significant role in shaping individual behaviors across life stages and are particularly influential in traffic context, especially in encouraging risky riding behavior. So coming to parental influence, so they play a key factor in determining the overall rider behavior. So the survey instrument used for the study is Motorized Two-Wheeler Rider Behavior Questionnaire. It is a self-reported survey tool that asks respondents to evaluate how often they engage in different riding behaviors while riding a motorized two-wheeler on a like-it scale ranging from never to almost all the time. Coming to the literature findings, so the peer pressure can influence others to engage in dangerous behaviors like drinking, speeding, or other illegal activities. And peer pressure can be a major factor in explaining, especially the teenage riders, who are more prone to participate in unsafe driving practices and involvement in traffic crashes. Youngsters' driving behaviors and mindsets are impacted by social interactions that their peers find acceptable. Padilla et al. 2023 found that males were more susceptible to peer pressure than females, although they found not much differences in the driving experience with respect to gender. Also, females who spoke more with their friends about the driving experiences tend to be more dedicated to safety outcomes. Bianchi and Sumala 2004 indicated that their parents' driving habits notably influence children's self-reported driving styles. So even after controlling for exposure and demographic variables like gender, age, the research showed that parental driving styles, specifically errors and the violations, were strongly correlated with the similar behaviors in the children. So lifestyle characteristics such as family connectedness had a greater impact on the children's aggressive driving behavior than parental driving behavior. There were also clear gender specific trends, with mothers' driving styles have a similar impact on daughters and father styles on the impact on their sons. So also the influence of parents plays a pivotal role in discouraging the riders from engaging in risky riding behavior. Okay. Coming to the research gap, the studies that consider both peer pressure and parental role on the influence of risky riding behavior of motorized two-wheeler riders are very limited. So, with the research gap in mind, the objective was framed as to investigate how parents and peers influence the risky riding behavior of motorized two-wheeler riders under mixed traffic conditions in countries like India. The scope is limited to self-reported perceptions of risky behavior of motorized two-wheeler riders in Indian traffic condition. It explicitly excludes racing riders and does not incorporate any on-road observational or simulation-based assessments. So, coming to the methodology, problem identification, then followed by design of the questionnaire. data collection, data curation, descriptive statistics, exploratory factor analysis, bivariate correlation, ordinary logistic regression model. So the model has been developed for both parameters, peer influence and family influence individually, followed by conclusions. So coming to the design of MRBQ, Elliott et al. 2007 originally developed the MRBQ for the UK riders. However, the direct application of this MRBQ to Indian context is limited as there is difference in rider psychology and traffic regulations in India. So to address this gap, a tailored version of the MRBQ was developed by revising the original items and incorporating additional questions relating to the common riding practices of Indian motorized two-wheeler riders so that the participants could easily understand and respond. Focus group discussions were conducted with 30 Indian motorized two-wheeler riders, 2 traffic police officers, 2 field experts, and 1 psychologist to assess the clarity of each and every question and to identify any unclear items. As a result, 12 items were excluded, 30 items were rephrased into 13 items, 21 new items were introduced, and 1 item remained unchanged, resulting in a total of 35 items in the stated version of the questionnaire. The questionnaire consists of 3 sections: socio-demographic, riding behavior, and rider perceptions on the influence of peer and family. Coming to the data collection was done in online mode and it was done across India via Google Forms using various marketing strategies such as sending group emails and social media promotions. A convenient sampling approach was adopted to gather participants, resulting in a total of 603 responses. So the questionnaires were the responses collected were cleaned using several filtering techniques such as question is completed under 5 minutes were discarded, following a requirement of 3 seconds per item rule, and those with uniform responses for more than 50% items were removed. So after eliminating 64 improper responses, 513 valid samples were retained, an effective data retention rate of 89.39%, and the preliminary analysis were carried out using SPSS software 22 version. The participant confidentiality was ensured as the questionnaire survey was entirely anonymous and did not collect any personal identifiable information. Coming to the descriptive statistics, majority of the respondents were male riders aged between 18 to 25 and 26 to 35, with mostly young riders and with educational level postgraduate and above. Most of the participants were student category and rode motorized two-wheeler engine capacity up to 125 cc. And most of them were experienced riders with greater than 3 years of riding experience. Most of them received unofficial training from either friends or family. And most of them performing work or educational trip, and the trip frequency is mostly daily trips. So coming to the crash history, so nearly 18% were experienced at least one or more crash in the past 3 years, and 25% experience at least one or more traffic violation in the past 3 years. Next, factor analysis. So principal component analysis with Varimax rotation suggested 8 factors initially. After conducting parallel analysis and Melissa's mock test, a 5-factor optimal solution was identified with 34 items explaining 67% of total variance. Items with the factor loading less than 0.3 was considered as as it show a poor association, so it was not included. As a result, item number 9, overtake a leader vehicle giving left or right turning indicator while turning, having a factor loading less than 0.3 was eliminated from the analysis. Based on literature review findings, the factors were named according to the relevance to the items. The factors were named as error, speed violation, stunt, safety violation, and ordinary violation. From the table, you can see the factor loading scores of all the 5 factors, and the cross loadings have been eliminated based on the previous studies. So coming to correlation analysis, here the dependent variable is frequency of riding, preferring risky riding behavior when riding with peers. So it is inferred that motorized two-wheeler ownership, self-reported violation, stunt, safety violation are insignificant, and self-reported crashes, error, speed violation, ordinary violation are positively correlated, and gender, age, riding experience, trip purpose were negatively correlated with the dependent variable. Coming to model 2, frequency of preferring risky riding under the family influence, error, stunt factor, safety violation, speed violation, self-reported crashes, gender showed insignificant result, whereas ordinary violation, self-reported violation, motorized two-wheeler ownership showed positive correlation, and age, riding experience, trip frequency showed negative correlation with the dependent variable. Coming to the model statistics, so the test of parallel lines is insignificant, which infers that the proportional odds assumption for the ordinary logistic model is satisfied. that is, the odds of falling into the higher category, remains consistent across all the categories of the dependent variable. The model fitting information is significant, which shows that the model has a significant performance over the null model, and the goodness of it Pearson is insignificant, which shows that the model adequately fits the data. The McFadden value indicates that 12.6% improvement in the model in prediction of frequency of preferring risky riding when riding with peers compared to the null model. Coming to the model results, the MRVQ factors, error, speed violation, ordinary violation, showed significant, and the frequency of the riders who are frequently involved in these behaviors experience engage in more frequent risky riding behaviors under peer influence. Male riders, young riders aged between 18 to 25, novice riders less than 1 year, riders who ride for educational trip, and riders with one or more crash history are prone to engage in risky riding behavior. Coming to the second model, so all the model fit statistics are satisfactory. The model result shows that the MRBQ factor ordinary violation found significant, and the riders who commit more ordinary violation are more prone to engage in risky riding behavior under family influence compared to riders with less frequent of these behaviors. Similarly, young riders aged between 18 to 25, riding experience less than 1 year, daily riders who are performing daily trips, and persons without motor ownership, and uh, uh, riders with at least one or more violation in the past 3 years are prone to engage in risky riding behavior compared to the counterparts. So coming to the conclusion, the modified MRBQ adapted for Indian traffic condition identified 5 key items, which are errors, speed violation, stunt, safety violation, and ordinary violation, effectively measuring the risky riding behaviors of motorized two-wheeler riders, explaining 67% of the total variance. The bivariate correlation analysis identified the significant predictors such as motorized two-wheeler ownership, self-reported crashes and violation, errors, speed violation, ordinary violation, gender, age, riding experience, trip purpose, and frequency. The study found that young riders aged between 18 to 25 and adult riders between 26 to 35, male with less experience, that is novice riders, less than 1 year of riding experience, performing discretionary trips and having a crash history were prone to perform ski riding under the peer influence. Similarly, young and adult riders with less experience, less than 1 year, occasional trip frequency, and history of traffic violation were prone to perform risky riding while riding with family. So coming to the implications, the model results emphasize the necessity of targeted measures to enhance road safety in countries like India, especially for the adolescent and adult novice riders who are having crash and violation histories. So some of the policies like mandate parental accountability, encourage simulators for rider training, promote target awareness campaigns are suggested based on this study. So that's all. Thank you for the opportunity.
Thank you very much. Thank you. It was so insightful. Is there any question here? Any question? All right, I have 3 questions myself. Can you please go to slide 7, number 7?
Yes.
Okay, my question is regarding the term item. Do you mean actually the variable by calling items?
Items mean the questions, sir. Questions in the
Questions.
measuring the rider behavior question.
All right. Could you please go to page, no, I don't know which page. I think next page. Go to the next page, page number 8. All right, as I can see, more than 90% of the population is less than 35 years old. Why? Why?
Yes, sir. Most of them were student category members, so that graduate, postgraduate, and doctoral students. So that's why, sir.
Okay, students has been the focus of your study, right?
Yes.
All right. And could you please go to page number 18?
Page number?
Yes,
Which number, sir?
18, 1 8.
Sir, last page number 16.
Oh, 16. Okay. Okay, I wrote something wrong here. You had a terminology. Yes, that one. The previous one. Yes. You have a terminology here. Total violation I can't see. Can you please? Total violation in the past 3 years. Can you please explain a little bit about this? What do you mean by total violation?
So violation means like red light violation, traffic violations, sir. So like it includes traffic violation, speed violation, and other violations which are violating the traffic safety rules. Like they were issued any
Okay,
traffic
it
challans.
covers any violation. Yeah.
Traffic challans mainly,
All right.
yes.
All right. Have you distinguished this in your other research, or do you have any plan for your future research to do that? For example, you categorize the violations and then evaluate that, or no?
Yes, sir. That has been added in the future scope of the study, and my juniors will be working on that.
All right. Thank you very much. Any other question here? Thank you very much. All
Thank you.
right, let's move on to the next presenter, who is let me have a look on the bio. Yeah, Dr. Kumar Tudadi. Are you here? Yes. He joined us. Dr. Kumar Tudadi is an assistant professor in transport engineering. He earned his master and PhD from the National Institute of Technology in Warangal, with research focusing on operating speed modeling on two-lane rural highways. Okay, go ahead. Just Dr. Tudadi, I want to add something. Actually, we have 5 minutes ahead of time, so you have plenty of time. You can just explain actually your topic with peace of mind a little bit.
You're not audible.
Dr. Tudadi, can you hear us?
Kiran Kumar, you are not audible.
Dr. Tudadi? All right. My suggestion is to move to the next presentation, and then we can come back to Dr. Tudadi as the next presenter or at the end of this session. Okay, the next presenter is Abdul Ahad, right?
Am I audible? I am Dr. Ravishekar. Am I audible?
I think, let me see. uh,
My after Kiran Kumar, my presentation, Ravishekar.
Actually, the third presentation, what's the topic? Oh, reliability based. Oh,
Okay, okay. Yeah. Now third presentation is going on, I think.
all right. This- yeah, actually, this is what I see on the screen is the next presentation, but it seems that he's not available for now. Okay. Your presentation is the fifth one, Ravi.
Is it fourth one or as per
The
schedule?
fifth one. No, it's the fifth one. The fourth one is Abdul Ahad. Is Abdul Ahad
Okay.
here?
Great. I will, yeah, okay.
Yeah.
Hey, Dr. Najmi.
Yes. Yes,
Uh,
Reza.
there is not, Abdul Ahad is not here,
All right.
and there is not any presentation uploaded in our Google Drive, unfortunately.
All right.
So we can continue to next one.
All right. All right. The next presenter is Ravi Sekhar. Let me just provide a short overview of actually his background. Dr. Sekhar is a chief scientist in the Transport Planning and Environment Division at Central Road Research Institute in New Delhi. He holds a PhD in civil engineering from Kobe University in Japan in 2008 and has over 20 years of experience in transport planning, traffic engineering, and travel demand modeling. Okay, go ahead. The floor is yours.
Yeah, thank you, Professor Ali Najmi. And this is Dr. Ravishekar. Can I, are you able to see my screen?
Yes, we can see.
Yeah. Thank you. First of all, thanks to the BTR for inviting me to and my co-authors to present the paper. So myself, Dr. C.H. Ravishekar, Chief Scientist in Central Road Research Institute, New Delhi. Today's my presentation is an identification of lane departure hotspot using an Indian interurban highway. My co-authors are Dev Singh Chakur, is a research scholar. Dr. Mukti Advani is a principal scientist, and Dr. S. Murugan is the chief scientist, and Dr. Ambuman Subramanian is a faculty in the IIIT Hyderabad. So today my presentation mainly focus on the motivation to start the work, research the work, and the objective and scope of the study, and the study area and data collection. We are mainly focusing as one alert, that is a lane departure warning alert. So how it will be benefit to the driver, how we can use in the real application, safety applications, and identification of lane departure hotspot, and validation of results. And as you know that in India, so in 2022, Minister of Road Transport and Highways and estimated the total accidents is a 0.4 million accidents, and out of this 0.16 are the fatality accidents and remaining are the injuries. So the main reason of accidents are particularly for the traffic rules violation, mainly overspeeding. So because the road posted speed limit, for example, 80 kmph or 70 kmph, what are the speed limit they are given? So overspeeding of the vehicle and drunken driving, lane discipline, changing of the lane discipline, jumping red light, and use of mobile phones, others. But in this, after the overspeeding, the lane indiscipline, so not following the lane, so that is a major second of the causes of the accidents. So mainly the accidents because of the human factor accounts for the 80% of the road accident. Remaining indiscipline, also literature suggested that so incorrect overtaking, high speed lane changes without indication of the lines, like either left signal or right signal. This leads to severe crashes and also run off road and head on collision and rear end side collision, lot of the things. So this how to quantify the thing, how to study the behavioral alert. So that is the one of the main object of the study. So this is mainly because India is having the heterogeneous traffic, because most of the European and other American cities, they have the 3-4 vehicles in that stream, but in India we have the 13 to 14 vehicles in the stream. So this kind of mixed vehicle, it is very difficult to drive on the particular road during the interurban highways, and also unpredictable driver lane following behavior and lack of real-time insights, and sustainability metrics index, something lack of sustainability metrics index. So these are the main problems we identified in the traffic behavior. And for that, our motivation is that so the advanced tools like AI tools like ADAS systems, automatic driver monitoring system, so this will be useful to study the behavior of the driver. So particularly the motivation is that human-related factor and lane discipline-related factor to be examined by using this device, and real-time driver intervention, because AID, ADAS and DMS, these are the one of the techniques will be very much useful for the driver observation and data-driven insights. So collection of data and inferences from the data. This is one of the main objects of the study. So as you know that the ADAS, most of the ADAS, they have the 5 life-saving features. One is that speed limit indicator. So for example, if you're given a speed limit threshold is 100, it will give an indicator beep like that. And forward collision warning, FCW, and pedestrian collision warning, PCW, in a shorter way, and lane departure warning. In this study, we are mainly focusing on lane departure warning alerts when there is an abrupt deviation from the driving lane. That is the definition of the LDW. And another one is a headway monitoring warning. So these are warnings. These devices we have installed in the public transportation bus system. So that one pilot based, we have identified the corridor. In Hyderabad, there is 3 corridors are there, interurban corridors. Interurban corridors means it's a rural highways. So coming from the connecting the 2 cities, major cities in one of the state in India, that is Andhra Pradesh. One is the capital city of Hyderabad, capital city of Telangana state, that is Hyderabad, and connected to the another city is that Vijayawada. So we have taken one corridor, that is the Hyderabad to Vijayawada. It is a corridor length is 190 kilometers, and we have installed 50 total. We have installed 100 devices, but in this particular corridor, we have installed 58 public devices in the public transit bus transport system, and that is the main the thing. But if you see, before going to the study the data complete in depth, so we have also reviewed the various literature. What are the benefit of the ADAS systems? You can see that various existing from the literature, you can identify that we can control the accidents 25% to 30%, 50%, various others. Like you can see the ADAS application, German 2021 studied heavy trucks lower crashes less than 23%, and fatality also reduced. And you can also see in 2023 North Dakota state, they have introduced the ADAS systems, and they have observed that 90% accidents can be reduced. So that is the literature. I have already studied about the advantage of the ADAS systems in useful of the reduce the crashes. But mainly the gap in the research is that the motivation of main study in this work is that, so most of the studies is related to the homogeneous kind of the traffic, because there is a 3 to 4 vehicle in the stream. But this study mainly focused on the Indian highway corridor, which is a heterogeneous traffic, and also the composition of the traffic will be varies every hour. There is a lot of changes in the traffic composition. That is the one of the advantages. So the main objective of this study is that, so the lane departure hotspot to identify on National Highway 65, that is from the Hyderabad to Kodada, and we have used the LDW alerts from ADAS devices. So the main scope, we have collected the data 58 instruments and almost 0.2 million kilometers fleet mileage. One particular month, December 2020, we have considered, and 190 kilometers test section out of 225 kilometers we have taken, and mainly focused on the LW alerts out of 5 alerts. You can see here why we have taken LW alert as a study, because the 82% of the alerts, which is the lane departure warning alerts. So this is the main consideration for this study. So the methodology includes one is the data collection from the ADAS installed buses, and then the LDW alert data collection. Then the data is normalized, and also application point density estimation, PDE estimation approach we are considered, because it is a simple approach. So the density oriented and the length per kilometer length we have taken. Then we have identified the hotspots based on the LW alerts. That is the main thing. You can see the corridor represent the study area and data collection. You can see the corridor. So the green one shows that LW alerts, and also you can see the black one. It shows the black spots enter the corridor. This is the actual black spots estimated by taking the last 3 years accident data, and then we have plotted on the GS platform, and also we have plotted LW alerts. Now these are the data we have considered and study area we have considered, and other details like road network details such as geometry conditions, other like number of intersections, a minor and major intersection. Those are the considered in the study area. And you can see here the generation of LW alert real time. It is a real time alert generation, and also you can see the corridor, how it was fixed and how we can extracted the data. Particularly this data we have collected for 1 month, 1st December to 1 year, that is the 1st December to 31st December 2022. 1 year data we have collected, and this data we have summarized here in the the main characters are the lane departure instance. It depends on various factors. Those factors are driver attributes, socio-demographic variables like age, gender, and other parameters, and vehicular characteristics, size of the vehicle and engine, etc. And road geometrics, particularly radius of curvature, lane width, and shoulder width. Because this corridor is a 4-lane divided carriageway, the median width is a 4 meters median, and the carriageway is a 7.5 meters plus 1.5 meters paved shoulder. Then the earthen shoulder is there. So this is a typical urban interurban highway. And the vehicles are more dominant vehicles are the car, and heavy vehicles like buses and like trucks are there. And after that, you can see here the alerts. Like we have provided the alerts in the daytime and the nighttime also segregated. Like LW alerts for the daytime and nighttime. Daytime we have observed 48%, nighttime is more alerts are there. And the speed-wise distribution alerts also, we have estimated the distribution of the speed. When the alerts were kept, particularly the modest speed is the 60 to 90 kilometers speed. We got the more number of alerts in this corridor, and you can see that what is the their behavior, like characteristics. For example, in earlier we studied that the overtaking behavior, those kind of the driver. But here we can correlate that whether the driver how he changing the lane. So because, for example, in a normal situation is a good driver, is following the lane, and then one is touching the lane mark and crossing the lane mark. So is a poor driving behavior without indication. Similarly, the second characters is that critical situation is that, for example, he suddenly jumped from without indicated from middle to the end of the lane marking. And as another approach is that suddenly jumping and overtaking to the another vehicle with a high speed. So these are the two critical situations observed in the phenomena of the driver behavior and also data sets also. So then what we did is we have separated the data, identified the combination of LW alerts within a 5 seconds time gap. For example, frequent LW alerts less than 5 seconds gap, and this combination often with a critical driving situation. So now this data we have considered into the data analysis. Now we have the data analysis steps are mainly 3 steps procedures we have considered. One is that hotspot detection by using the RGS with the PDE techniques. It is a point density estimation, because the standard practice of black spot analysis is the corridor length is 500 meters. So similar way we have taken the data every 500 meters how many alerts are generated, then per density we have estimated. Then we have done for the k-means cluster analysis for a speed categorization, and we have correlated with the separated the data for the daytime and the nighttime by using the SPSS techniques. We have done the k-means cluster analysis, then lane tip hotspot. This is a major study, because we have to correlate with the existing black spot and identify, then provide the detailed suggestions to the engineers, executive engineers, which are they're going to implement on the ground. Then they will rectify the problems and they will reduce the accident. That is the motto. Not only we are supplied the detailed project report for them. So the point density estimation is very simple. It is a cloud-based. So number of points divided by the cell area. Then we have estimated the contact. This is the procedure adapted for the step 1 hotspot identification. Prepare the GIS database and applied the PDE into the RGS platform. Then density we have estimated. Then separate the k-means cluster by using the k-means cluster approaches. And then we have made like a severe, very severe, and different categories. And finally, we have correlated with the speed also. So from this k-means clustering analysis, like what we have observed, LW alerts are speed data, 7,317 daytime and 6,721 elements, entities are their nighttime samples to classify art speed and this one. What are the things we have observed in daytime and nighttime from ANOVA results, like analysis variance results, like sum squared error and the other within the group and the mean square error between the group, we have observed that. So the validation of the highest F value, that means very significant observations during the daytime and new time of the like alerts are there, significantly observed. And also the clusters are the three clusters. One is the mild clusters. The daytime, the speed is less than 54 kmph, and severe 66 kmph and above, and very severe is more than 70, because this corridor is a like speed limit already provided. So the speed limit varies between 60 to 80, because it is a curvy section. They provide the 60 kmph. It is a straight section. It is provided the 80 kmph is a speed limit section. So similarly, what we that we have made a hotspot, like we have provided the mapping kind of the things and the hotspot locations. You can see the daytime and nighttime. So the hotspot normal is a gray color, and mild is a blue color, and yellow color is a severe, and very severe is a red color. So these hotspots will be visited site, and also we have examined the proper region geometry kind of things, and we have provided the geometric improvement detailed drawings to the client, and client like implemented on ground to further improvement of the, for example, like any kind of the road safety measures, road safety audit, those kind of the situation they provided. So like this is the daytime and nighttime you compared, and the locations particularly we have identified in 4 locations. Those are the critical locations in the daytime, and also nighttime we have identified the 5 locations. Those location stretches, not location. These are the stretches. Those stretches are significant to taken care about road safety audit as well as the junction improvement or geometry improvements. So the finally come to results and results. Daytime findings, we have 4 very severe hotspot locations. As I explained, nighttime also we have identified 5 locations, and then validation of insights. We have also correlated the black spot, and we have checked whether this alerts, whether really good alerts are the fake alerts. That can be compared with the past accidents data, and also we have ground visit, and finally we have finalized the verification and validation by comparing with the ground. So final, my last slide, I would like to discuss about the result. Finally, the main key findings of the study is that so ADAS-based LW alerts are very help to find out the high-risk zones, which can be helped to reduce the accident hotspot zones, then can be taken care. And analysis of LW alerts combination less than 5-second gap is the revealed risky behavior such as abrupt lane change without indicators. So this can policy measure we can taken care and give it training to drivers, because the public transportation system, bus transport system managed by the government of Telangana state government, the driver can be given a training, and we can give a training to taken care while changing the lane. The third point is the hotspot identify the PDE, which is useful to segregate the K-means clustering and speed data. And we have given a recommendation soft speed calming measures like TBM transfer bar benchmark markings, and also signage, road marking, road safety audit we have done. So these are all done, and also finally the aim is that geometric corrections. For example, any radius of curvature or maybe any kind of the corrections in the geometry, we have redesigned the geometry and submitted to the client. So the results already I have discussed. The limit of the study is that we have done the study for the one corridor that is 190 kilometers. Further, we are going to expand into the 2 more corridors for implementation of this LW alerts. So that is about my presentation, and these are the references which are considered during my study, and that is about the end of my presentation. And thank you for kind listening about my presentation. Thank you.
Thank you very much. Thank you very much, Dr. Ravi Sekar. It was a really insightful presentation, and I really enjoyed that. It addressed how we can find hotspots in urban area. It was, yeah, I like it. Does anyone have any question within the attendees? No? Okay, I want to ask a question.
Yeah,
Can you
proceed.
please go to page number 15?
Page number 15.
15, yeah, you were talking about the K-means.
Yeah, this one.
K-means, which slide was the K-mean? No, the previous one, I think. Yes, that
Yeah.
one. Yeah. I see there are actually a few speeds. You categorize them based on mild, severe, and very severe, right? That's the output of the K-mean or no?
Pardon? Output?
Actually, those values, 66
Yeah.
kilometer per hour, or for example, 54 kilometer per hour, that's the output of K-mean, or
Yeah,
how do you?
output of the cluster, we have like we have the speed distribution, and we
Yes.
have the alerts and the vehicle speed at the particular location. We have the
Yeah, and,
alerts
and
are,
that's the average of those. Okay.
yeah, yeah. That is a cluster of that one. K means cluster means we
Yeah.
have made it into the three clusters. And generally the range, what you suggested,
Yeah.
Professor,
Right.
so it will be range, but we have taken at the mid value of that one.
Yeah.
So that is a critical parameter.
Yeah. Regarding the ADAS actually equipment that you showed in your pictures, does that designed for the public transport, or it can be, for example, on other equipments like, what can I say, like the bicycles, the private cars, or everything?
Very good question, Professor. In the initial, the government has implemented for the public transportation system to
Yeah.
monitor. So further private transport, this can be applicable private transportation like a passenger cars. But in
Yeah.
the case of two-wheeler, this is a like we have the stakeholder meeting at in Indian Institute of Technology, IIT Hyderabad recently. So the same question was asked by the other professor. So like if you see the implementation of the two-wheeler behavior is completely different. So particularly in Indian and Asian countries. So the device, for example, the position of the device, fixing a device in a bus, in a car, it can be similar kind of like. But in the case of a two-wheeler, the fixing of the camera, it is a like challenging one. The distance between the camera and other thing, and the side mirror, the behavior and the thing. So it is some other like studies to be required. Pilot based. In India, there is no implementation on the two-wheelers, but that like this was done in the like simulator. Like for example, if you provided a simulator, you provided the ADA system, how the driver behave, simulator studies done, but practically it was not started. So probably in future we will focus to implement in the two-wheelers.
All right. Can you please just give me an estimation of the cost of each equipment?
Yeah. Now, in that 5 years back, the ADAS equipment is similarly very cost. But now there are mass production like mobile company and other various companies came to India. So now there is now earlier there is a two different devices. One is a ADAS device and DMS is complete two different devices.
Yeah.
Now people are combined with ADAS and DMS. The equipment cost is around 40,000 Indian rupees. So probably by $400 like it's divided by 100, so probably like $400 to $500. And this is a device. Once you fix the device, you need to take the cloud database. So cloud database is a monthly base. So if you go for any Airtel, any kind of telephonic vendors, they can give the database on a monthly basis. Recently, Amazon they implemented in the freight zone and a live database for Indian trucks for their trucks. So they implemented in a trucks. They have driving behavior. Truck driver is different. So probably by $500 to $700, we can spend for a month.
All right. Thank you very much for the time.
Yeah. Thank you so
Okay.
much. Thank you for kind.
Let's move on to the next presenter. Dr. Tudadi, are you here?
Sir, I am here.
Okay. Hope you have resolved that issue.
Yes, sir, resolved, sir.
Okay, go ahead. The floor is yours.
Thank you, sir. Sir, am I visible, sir?
Yes, all good.
Okay. Thank you, sir. Sir, myself, Kiran Kumar, and my co-author is Dr. Arpan Mehar. And today I am here to present my research topic, reliability-based evaluation of horizontal curve design parameters for two-lane rural highways. And before going to introduction, what is reliability and how the system fails? So here, why reliability analysis is introduced in the horizontal curve design and some other. So reliability is mainly due to any component a system will perform a required function for a designated period when used under the specific conditions. So generally, reliability is measured by using the limit state function. A limit state function is the mainly the difference between the supply and demand. Suppose If supply is more than the demand, there is no problem. Suppose if demand is more than the supply, the system or component will fail. So due to this, what happened, higher chances of accidents are happened in the at the horizontal curves. So here the reliability concept is applied to design the some of the geometry design parameters. So this generally after applying this, we are calculating the reliability. Based on that, we are calculate one factor. That factor is resulting factor is known as the probability of non-confidence, which is related to the probability that means demand is more than the supply. So, however, this reliability and supplementary technique for the assessing safety in the safety in terms of risk at horizontal curves. So, these are the few studies he presented here decade wise. So, the main objective of the study is to develop the safety evaluation criteria by considering two parameters, that is stopping side distance and slope elevation, by using the two different types of reliability analysis, that is single mode and multi-mode reliability analysis on two-lane rural highways. After developing this, we are proposing some recommendations, and thereafter we are developing some calibration charts for with different target levels of the probability of non-confidence, that is 1%, 5%, 10%, or 50% of PNC values. So after developing this to assess the safety implications of different design choices. So this is the this one is site selection. So before going to select site selection, we are considering the different parameters. Suppose this for considering the speed and some other speed values, we are considering the site as pavement should be good and dry condition and uniform width at the tangent section and curved section, and the site should not be nearer to any built up areas, and the selected site should not influence with the any other intersections, and at the same time there is no physical activities or any adjacent to the selected site. So by considering all based on the following criteria, we are selected the a total of 82 sites, out of which 41 sites are horizontal curves, 41 are tangent sections. These are selected along the three different national highways in India. Namely, it is National Highway 163, National Highway 365B, and National Highway 563. These highways are located in Telangana, India country, and these are the three different locations. That is, these are the schematic diagrams, and these are the real pictures of curve section and tangent section along the three different national highways. After that, we are collecting the different data. That is, the data collection effort mainly consists of the both geometric data and speed data. So geometric data is mainly measured by using the total station equipment. So in the geometric parameters are curve radius, curve length, stopping side distance, deflection angle, degree of curvature, carriage width, shoulders. These are measured by using the total station. Thereafter, we are measuring the stopping side distance and slope elevation also. Here, this picture shows the measurement of available side distance on the horizontal curves. Suppose total highway section at the horizontal curve is before the horizontal curve and before the point of curvature, we can divide the total sections in Z1, Z2, and Z3. So Z1 indicates that available side distance 1, and Z2 indicates that available side distance 2, and Z3 indicating that available side distance 3. Similarly, ASD4, ASD5, ASD. After that, we are measuring the distance. Finally, we consider which one is the minimum distance, which one is the critical. That indicates that higher chances, less reaction time, it leads to the higher chances of accidents. So similarly, we can measure the slope elevation also. Slope elevation is measured with reference to, that is, level difference between the inner and outer edge of the pavement by using the leveling and total station also. After that, we are extracting some data. This data is extracted by using this data. That is, we can develop modeling, and here we are collecting the data at different points. That is a tangent section and point of curvature, midpoint of the curve, and point of tangency. Now, how the reliability is measured, and so here generally we are considering the two types of parameters, that is stopping side distance and slope elevation. So how we calculated reliability based on the stopping side distance? So first of all, we calculated the limit state function by using G equal to supply, that is supply of this supply or available side distance minus that is demanded stopping side distance. So this one is supply, means that one is available from the field, and demanded is calculated by using this formula, that is 0.278 Vt plus V square by 254 F. So here the V is the vehicle speed, that is the operating speed. Operating speed is measured by using the radar guns in field. So same speed we use it to calculate the demanded stopping side distance. And similarly for another parameter is super elevation. So in here G equal, that is limit state function, equal to supply minus demand, that is supply of the super elevation minus demanded of the super elevation. Here the supply is measured by taking the difference in elevation between the inner edge and outer edge. That is, if pavement is rotated from inner to outer edge. Suppose if the pavement is rotated, that is center of the pavement, we can take the difference in level between the center of the pavement to the outer edge of the pavement. So after the demanded slope elevation is calculated by using the V square by 225 R. So by using this formula, that is reliability analysis is performed. So this table shows the reliability analysis results based on the both slope elevation and stopping side distance. Here the first column is indicating that curve numbers. So these are the different total of 41 curve sections and 41 tangent sections, as I mentioned earlier. So here curve sections, the SSAD is indicating that is supply of the stopping side distance and demanded. So after first of all, we calculated the difference between these two, that is the beta. So limit, that is margin we calculated. Based on margin, we can calculate the beta SS, that is reliability values. So here we can observe, it can be observed that almost all the sections having the, that is supply is more than the demand sector, demanded stopping side distance, but except only two sections are bottom, that is 26 and these two 26 and 30, these two are having the demanded super elevation is more than the supply super elevation. That means that the failure that is why this is the negative value. So here coming to PNC values, almost all as the positive values, but this one is bottom two is the higher probability of occurrence of the accidents, because this demanded is more than the supply. So this is based on the stopping side distance consideration. And another observation is this beta value, only 10% of sections having this beta value more than 3%, remaining all are less than 3%, only two sections having negative values. So almost all only 10 sections having the 3%. That means if the reliability is more than 3, generally we can consider it as occurrence of the accidents are less compared to less than 3. So here another criteria, that is super elevation. Similarly, curve numbers, and that is SC supply and demand. After that, we calculated the margin. So based on that, we calculated the beta value, reliability values. So while coming to this one, here it can be observed that majority of sections, almost all sections, there is no section having the beta value less than the 3 only. Means almost all sections have beta value less than 3. But here observe that 5 sections having this value is more than the, that is demanded is more than the supply. So almost all 5 sections having negative values. That means that the higher probability of occurrence of the accidents by considering the super elevation. So here what we observed, that is suppose if we consider single mode as, that is stopping side distance, only 2 sections failure. So that means demanded is more than the supply condition. And at the same horizontal cost, the different horizontal cost, we consider super elevation as a failure function. So we here 5 sections are more than the negative value. That means demanded value is more than. So suppose if the section having negative value, that means that 50% of failure condition. So here, what we observe, that is suppose if the negative value shows the more chances of accident due to high demand requirements, as the probability of non-conformance found to be greater than. So if this negative value means more than 50%, as per Hims, Donald 2000 and Abraham Syed. So, and already we discussed that here only 2 sections, here 5 sections, and here some graphs are drawn in between the safety margin, PNC, that is the A is for stopping side distance, and B is for safety margin and PNC value. Similarly, for reliability index versus PNC values, and reliability index versus this PNC for super elevation. And now coming to, so here there is a disparity between the single mode, because while considering SSD only 2 sections fail, while considering the stopping side distance 5 sections fail. So there is a disparity between the 2 failure conditions. That is why we can combine the two parameters into two parameters, and we are applying the more than one parameter, that is the multimode or system reliability analysis. So here we are combining both SSD and super elevation. So super elevation. So here the general system reliability is classified into two types, that is the series and parallel. In this we are adopting the series for two modes, that is SSD and super elevation. And this is the results of the system reliability analysis. So here what we observed, that here more than nearly approximately 8 to 10 sections having the reliability values more than 3%, and here the failure condition is six sections. So by considering SSD 2 sections, by considering E value is 5 sections, but when we combined these two into single failure mode, we can observe that 6 sections are failure. So that means the probability of non-confidence is more than 50%. So after developing, after result analysis, after that we have developed some safety evaluation criteria. So here we considered failure mode first, SSD, super elevation, and reliability analysis. So thereafter we applying the K-means clustering analysis. So by using K-means clustering analysis, we determined the optimum number of clusters. So here we are using the Silhouette Whittlesey technique to determine the optimum number of clusters. So thereafter we can divide the curves into unsafe condition, safe condition, and tolerable and poor condition. So here this result shows the first one is reliability of the SSD by considering this one, and so super elevation, system reliability. So in almost all the three, we observed that the total number of optimum number of clusters equal to 3. Hence the curves are divided into tolerable, that is level of unsafe condition, tolerable condition, and safe condition. So here this is the safety evaluation criteria for horizontal curves. So here stopping side distance, that is single mode, and this one is the system reliability. Suppose here reliability index value is there. Suppose beta is less than or equal to 1.9, the corresponding curve is unsafe condition. And suppose if it is less 1.2 to 2. Less than or equal to 2.02, the condition of the curve is tolerable. If it is greater than 2.02, that is safe condition. Similarly, we can develop safety criteria for super elevation and system reliability also. So after developing the safety evaluation criteria, we are proposing some safety measures based on the IRC and FHW, Federal Administration, that is. So here, suppose if it is an unsafe condition, so we are suggesting that provide some warning boards like accident prone, rumble strips, and safety barriers, markings, overtaking zone, use that speed control measures. Similarly, for tolerable condition, so we are suggesting some optical speed bars, traffic signboards, that is curve ahead, speed breakers, etc. And suppose if it is even though it is just a safe curve, we are providing some signboards already existed, that is curve ahead, lane markings, and road markings. So here, that is safety criteria, develop the safety evaluation criteria. Based on that, we are give some recommendations, safety measures at the curves for different levels of curves. So after developing the criteria, we are developing some calibration charts. So here the present study considered the middle ordinate as the for calibration of horizontal curves. So here, and next one is the different target values, that is if PNC will use 5%, 10%, 15%, and 15%. So how to calculate the G of X, that is PNC value. So this formula is generally we adopted to calculate the G of X value. So here RV is the curve radius and M is the middle ordinate, and V85 is the operating speed, reaction time, and friction. So we are taking some values. Generally, this RV is varying from 100 to 900 meters. Speed is varying from 30 to 80 kmph, and reaction time is 2.5 seconds, and longitudinal friction is 0.8. So by taking these values, thereafter we develop different charts. Here different charts, that is on x-axis is the middle ordinate, and this one is horizontal curve radius. These lines are indicating, that is different speed values, that is it is varies from generally 30 to 80 kmph. So here for 4 different target levels, suppose if probability of non-confidence 1%, this curve is adapted, and this one is PNC is 5%, 10%, and 15%. So for example, if we know the if we want to we know the radius of the curve and speed, corresponding middle ordinate is provided at the horizontal course. So this is the safety point. So similarly for all the PNC values. So thereafter, before concluding this, we are these are the different conclusions. That means what we observed, that if the stopping side distance is greater than 156 meters, that means the safe conditions, and there is less chances of accidents. And among them, only 10% sections have the reliability value is more than 3. But while we considering soap elevation, there is no section having the reliability value more than 3%. That means that higher chances of accidents. Due to this disparity, we are combining the two parameters, and after that we adopted the system or multimode reliability analysis. In this, what we observed, that different sections are having failure condition is different. So better to choose system reliability over the single mode multimode analysis. So after that, we are developing calibration charts for calculating the middle ordinate by considering the different radius values and different speed. So these are the references, and thank you.
Thank you very much. It was a great presentation. Is there any question from the presenter? Is there any question? Thank you very much, Dr. Tudadi. Thank you.
Thank you.
Reza, do we have actually Abdul Ahad, Dr. Abdul Ahad, or no?
Not now, dear Ali.
Okay.
I sent an email to Dr. Ali. He was wrong about the time, but I informed him to join our meeting. I'm waiting for that.
All right. Okay. The next presentation might be the last one, unless we have actually Dr. Abdul Ahad in the next 20 minutes. Otherwise, this would be the last one. I invite Mr. Tezuram Chandra. Are you here?
Hi, sir.
Hello. Actually, Tezura is a second-year PhD student at National Institute of Technology in India. Okay, go ahead. Thank you.
Yes, sir. I will present my screen, sir.
Please share your screen.
Sir, my screen is visible, sir.
Yeah, you can see now.
Yeah, yes, sir. Yes. Yes, sir. Good evening, sir.
Yeah, go ahead.
Yes, sir. Actually, thank you for the opportunity given the BTR conference, and myself, Tejoram. I'm pursuing as a PhD research scholar second year at NIT Puducherry, India. And as per my research topic was in assessing driving behavior of heavy vehicle drivers in India, and especially in truck drivers. As per this study, a questionnaire-based was taken, and this is my outline of this presentation. It was mentioned like a research motivation and literature and research methodology and so on. And while coming to this thing, according to the WHO, globally the road traffic crashes cause approximately 1.3 million deaths in each year. So by focusing on these things, I'm actually focusing on low and middle income countries, bearing around 93% of world's road traffic fatalities, and it's despite having a 60% of the world vehicles. And when coming to the traffic accident, it was the global level. This was the 8th leading cause of deaths across all age groups, all age categories, and especially mainly focusing on the vulnerable groups are the children and the young adults. And we complete the report. And while coming to the transportation sector in India, it was the backbone of India's economy, and handling the 67% of truck freight traffic actually. And however, in heavy vehicle, that is especially for truck, and the physical and mental demand, and it involves long haul truck and disturbed sleep and limited access to the uh, care facilities. And when coming to this, their occupational measures and their biophysical profiles of vehicle drivers, it impacts their driving behavior while in the day-to-day. And sir, my screen is moving, sir, or not, sir? Yes, sir. As per India ranks first among the 199 countries, accounting for 11% of global road deaths, that's, in road crashes. I mean, the mainly focusing on the commercial vehicle and fatigue, driver due to the fatigue oriented. And in this existing, we consider that health maintenance of behavior and psychological strain and regional disparities that we consider. And based on some policies interventions, whether we can able to make some improvement to in their driving behavior, also make some comprehensive make a questionnaire and to find the evidence based policies and to make a target intervention. And these are my literature review, which was I supposed to do in it was some one report on Amodu that 2025 reported that only 14.2% truck drivers met daily hydration needs, and linking that dehydration to impair the cognition and high crash risks. And coming to another studies like Ashmi and Mari Saminathan found that errors, lapses, and violations raise crash risk with age. And marital status and among the smoking as a key predictors among Indian truck drivers. As we coming to the distress and to the main fatigue or financial stress and the loneliness, it make some the difference in the working pattern and all those things. And while coming to this research objective, I need to identify the key factors which was influencing their driving behavior in the aspect of demographic and health and well-being, conduct the statistics and by connecting the EFA and CFA to validate the data which I collected, and from those after the CFA, I need to develop the other models which will be possible in finding the which behavior it will be having impact to occur the crash severity. Why I taken this research objective means when not research this problem compared to there are so many vehicle categories in two-wheeler and four-wheeler, and when coming to the accident, the impact of heavy vehicle that will be huge. Majority of the accident it may be in the bottom line of the like fatalities or in the serious conditions which will be require the ICU in hospitalization. So by addressing this type of behavior and to improve the driving behavior to increase the road safety in external India. This is my methodology, like focusing on the research objectives and selecting the study location and structural questionnaires in frame based on these two parameters and the data analysis. And in data analysis, I perform these three things. And after that, from those results, what I can going to do in the further. And this is the India, and I was focusing on this location which was highlighted, and the selection of the study spots. We went for a face-to-face interview, and through these locations, the petrol bank and truck light base and near the NH in the route of the small cities like Karikal and Puducherry, and near to the Tamil Nadu locations like Nagapatnam, and near the something we focused on. And this is the main focused location we spotted. And in the study location was like petrol banks or petrol stations or field stations we focused, and parcel centers, and to go to the face-to-face interview like this. And in this questionnaire, we make a face-to-face interview. A cross-sectional survey was performed, and from this survey, we collected like 210 responses survey. And from this, after screening all those things, and we got a valid of 196 male truck drivers. And this was conducted like November 24 to Jan 2025. And uh, these are the descriptive statistics having a driving experience, having a majority having 5 to 10 experience we collected in this, and also 34% of the drivers have more than 15 years experience in the driving professions, and some of them they having due to their education level, how they are understanding those things in and while driving the in Indian scenario and also in some other situations. And while coming to the health and well-being considered, we will consider like BMI, that body mass index of the vehicle truck drivers. And in this, it was mentioned like 30.1 percentage of truck drivers said like overweighted based on their weight and like and also we considered how many breaks they are taking in their long drives. Whether they, if in this condition, the long drives means the persons who are traveling more than 300 kilometer or near to the 250 to 300 kilometers who are traveling in that route, they consider as a long, greater than those things. And while going there, whether they feel fatigue or not due to these things. And other thing we consider like whether they experience a stress or anxiety. That's we as a question. And in meal, they are taking wealthy meals or not, or having some engage in physical exercise, and whether they are having screenings in how many they are, in which parameter, in which point of they are. In as per coming to the undergoing health screenings, they mentioned like 36 percentages of the drivers they won't do actually in many of the situations. They came in a serious condition, then only they are coming to the at least once or twice in the year they coming to the screening. And while coming to after this, I performed a reliability analysis using the Jombovi software, and which is this free software with having embedded in R coding and all those things. And using these things, I performed a reliability analysis and EFA and CFA, conformity factor analysis. And from this, I occur the reliability. That means it comes ranges between 0.469 to 0.73 with the Cronbach's value. It was explaining that how much the internal consistency of between the factors are there. And when coming to the EFA, it identified three latent structures, and it is acceptable the sample average is 0.73. As per criteria, it is the acceptable. And the model explained was 33 was 0.18 of total variance. This was a little bit low. While coming to social science studies like in behavior or in psychological parameter, it was studied in an article, and they mentioned for social science studies it should be like between range of 15 to 50 to 60 percentage of the factors should be explained. And through these three latent, it was explained that is psychological strain and demographic attributes and health maintenance in the things. And CFA, that while coming to after developing this model, it was times marginal. And so to evaluate these things, I was improvised that model. And to improve the model, I remove some weak and noisy variables which contain low loadings and high uniqueness and low KMO values that I discarded. And these are the values, these are the things I was discarded. Also, I need to take into account when coming to the health issues noticed with driving and refreshment patterns also should be impact. No need to, that means for improving the model, that parameter should not be excluded. That is that you need to think in logical way. If it is not required, that should be there. And again I reanalyzed and I performed, and from this time it was explained 56 percentage, 57 percentage of total variance it was explained. And four factors it was considered. And in that first factor, it was a driving induced emotional strain, fatigue and anger, and this all falls under this category. And second is falls on demographic, like age, experience, and their history of crashes or something related to this thing. And health maintenance, that they're making workouts or meals, or whether they're taking screenings. And mean transit health habits means inside the cabin, which were in the truck, that it was having the sufficient facilities to have the to monitor their health when they are not in landfill. And coming to the other that means model the EFA, and it was mentioned Bartlett test and KMO, it was similar to, it was okay, but when coming to the PL, it is not significant. And coming to the model fit, the RMSE is good, and like TLA also it's performed good, and BIC and compared to previous model it was improved in EFA, and factor loading it was improved like 56 points. It was explained through these factors. And while coming to the after selecting these things, I was taking account into the CFA. In this the CFA and the test for exact fit is little bit okay. It was acceptable, but not in p value. But should be there some other modification should be there. And then while coming to the fit, the CFA is not in the I'm not acceptable limit. It should be greater than 0.9, and TLI also it's not in the marginal. And RMSA is okay, but it's but due to this 2 to 3 fit is not eligible, means that should be reconsidered, and we need to do the. And these are the factor loadings with modification indices, and these things are I need to consider, and I need to make a different thing. Different, I need to remove something to improve the other parameters which I need to consider. And while coming to the summary of this thing, the strong factor is structured in refined EFA and is improved, but in CFA parameter I need to do some refinement, and then I need to do other possibilities what should be the considered logical way. And it is just explained 57% total variance, whether it is acceptable in social science. I previously said in social science, in driving behavior or in behavior and psychological studies, it should be having a range of 50 to 60 percentage. And each factor it was validated, and it by weak interfactor that correlation. And that I'm making I modification indices for hydration and health meals, and physical workouts in health and well-being parameter that should be having some cross loadings, and there is some weak alignment is there that should be addressed and need to be removed, and I need to work on these things. And in CFA it was accepted, but it should be having some uh, it accepted in some 2 to 3 parameter, but it's not in every parameter. So when coming to the results, some discussions, this study has developed and validated a questionnaire assessing demographic and emotional and health related factors influencing heavy vehicle, especially for truck drivers, to behavior in India to improve their road safety in Indian condition. After refining these factors, a four-factor model that four factors it expect 56% due to 57, and it solidly understanding the key driving risk dominance it was linked. And the CFA has confirmed the constant validities, emotional strain, and demographic health interactions, and laying the groundwork for predictive model in further using that SEM analysis or other machine learning models which will be uh, replicate to, or which will fits to the models. And also a little bit refinement should be done, and I need to work on this modification indexes. And when coming to the future work, uh, to expand this data set, I consider only these small regions, and I need to consider like generalist, it should be there. And instead of going to self-reporting, I need to record these driving logs and health screening or some violation records should be. And from this, I need to perform the SEM analysis, and implement and machine learning methods like random forest or XGBoost or in LLM models, to which will be having some unpredictable links will be the consider. And from this we can able to take some policies through the transport unions or logistics, and through making pilot studies. And while coming to this driving safety legislation, so to maybe improve by evidence based, and we can say to the for longer truck sectors. And these are my references. And I'm going to conclude by saying the quotes like actually the behavior behind that wheels drives the nation's safety. They need to be caution on while they're going to the roads. Thank you, sir.
Thank you very much. Thank you very much for the presentation. Does anybody have any question? No question? Okay, let me ask one question by myself. Can you please go to page number 14?
14, sir?
Yes, 14.
Yes, sir.
Yes. I want to have a look at question number 16. How
Yes, sir.
often do you feel drowsiness while driving? You are directly asking the drivers about their drowsiness, right?
They're asking driver, sir.
Asking the
Yeah.
driver, okay. But their perception might be different, you know. For example, for a particular driver, he can be, for example, have actually feel always drowsiness, but for the others, for example, for another driver, he can drive for 10 hours without any
Taking
drowsiness or
rest.
something. So their perception of the drowsiness can be different. How do you capture that? How did you capture that?
I didn't capture, but I asking their questions in what type in a week or in a past 2 weeks you are traveled. In that, how many times you are have the same feeling? 2 to 3 times or 4 to 5 times, and also I'm making in a like questionnaire options. In a week, how many times you have perform? In a week, how many you have got the experience like feeling drowsiness? Or questionnaire, that means in a month how much you have like I just asked their question, and few of them they said genuinely, but few of them they didn't say reveal the truth actually. But in the social science studies, when coming to this factor explained in each factor, um, due to this noisy and due to some data transparency, the when some error will be there. So to eradicate these things, to improve the like data collection method, or I need to do monitoring or something. I need to equip
Yeah,
something to monitor those parameter.
yeah,
But
yeah.
when coming to asking, they are saying some are genuine, some they are not saying like exact what they are feeling.
Yes, actually, by some assumptions, yes, you can assume that this question is correct, but it would be better, for example, ask this question or the questions like this indirectly. By asking several questions, you will indirectly reach the answer of these questions. This is what actually the researchers in social behavior or behavioral modeling they do.
Yes, sir.
Just for your future research. Thank you very much for the presentation.
Yes, sir.